Hello YouTube land. Yeah, it's lockdown here. It's getting worse and worse and worse and worse and worse. So I'm entertaining myself by making silly YouTube videos. This one's going to be a bit interesting, a little bit different. I was thinking about the nature of electromagnetic guitar pickups and wondering really what is the difference between single coils and humbuckers, and what's the difference between having 3 single coil pickups or 2 humbuckers in terms of the tone, the sound that you would expect to be able to get out of the guitar. And to really dissect that, we're going to have to go back to some fundamental laws of physics. Years and years ago, way back in the Jurassic era, when I did my O-levels, I did physics, chemistry, biology, whatever, all those subjects. We learned in physics that the force applied to a wire that contains a current moving in a magnetic field is always perpendicular to the magnetic field and perpendicular to the current. That's the principle. Magnetic field, electric field, force. These 3 things all interact with each other at right angles. Andy, stop. Why are you going on about coloured pens? What's that got to do with electric guitar pickups? Bear with. Okay, here we go. Electric guitar pickups. Here's a guitar pickup. That's a coil. Everybody knows that's a coil. It contains a magnet, and wrapped around the magnet is a piece of copper wire. Now, it's a fixed permanent magnet, and when you move a wire in the magnetic field, that induces a current in the wire. It doesn't work with nylon strings, it only works with conducting strings. But because that's now a moving current, that is creating a magnetic field. And a moving magnetic field will induce a current in any other wires which are nearby. And the fact that there's a coil going round and round and round the magnet, and this moving current is now moving close to that wire, that induces a current in the coil. Further, why are there 3 sets of pickups? And why do they sound different? Right, so here's my string, conducting wire, and if it's moving up and down in a magnetic field in the same direction as the magnetic field, no current. It's moving across, it gets a current, and therefore it will induce a current in the coil. But the string doesn't vibrate like that. It doesn't just do a simple up and down sine wave. It actually goes round and round and round. Right, come with me, we're going outside. So I've got this application on my phone to identify birds by the sound that they make, and it's got this wonderful spectral analysis of sound. Now I'm going to play the high E string and the harmonic, and we're going to see what we can see in the spectral analysis. Here we go. Then I realised I could actually put 4 traces on the same screen to compare them. So what we've got is the root of the top E string, the 2nd harmonic on the 12th fret, the 3rd harmonic on the 7th fret, and the 4th harmonic on the 5th fret. We can compare them. What's amazing is the number of different frequencies that there are in the trace on the open string. put this into some sort of perspective, the second harmonic has a frequency of about 1.3 kilohertz. The fourth harmonic is a frequency of about 2.6 kilohertz. The eighth harmonic is about 5.3 kilohertz. And the 16th harmonic would be about 10.5 kilohertz. The 32nd harmonic, that's 1/32 of the length of the string, or around about 2 centimeters of the string vibrating, would be beyond the range of human hearing at 21 kilohertz. We can't hear that. Yeah, Andy, that's all very interesting and all very entertaining, but all of that's on an acoustic guitar, and you can hear all of the richness of the tone. Pickups on an electric guitar are only picking up the vibrations at the point of the pickup. They won't be hearing all of those harmonic frequencies, will they? What happens if one of the harmonics happens to have a node at exactly above the pickup? You won't hear that one, will you? You know what? You're right. Right. Here's the second harmonic. Here is the third harmonic. You can hear all of those. Here's the fourth harmonic. Hang on. Where's my fourth harmonic? Interesting. Here's the fifth harmonic. I can hear that one. What's wrong with my fourth harmonic? I could just about hear it, but not very well. There are places in the harmonics where they're called nodes, where the string isn't moving at all. It's moving on one side and on the other side, but not actually at that node. And what we've got here is a pickup which is very, very, very close to 1/4 of the length of the open string. In other words, it won't pick up any harmonics that have a node at that point. And the same is true of the other pickups. Any harmonic that has a node over those pickups, it won't detect. So you'll get a different mix of sound from the pickups in the different positions. Now it's beginning to fall into place why they sound different. I think that's enough. I think I've made it complicated enough. Thank you very much for watching. Catch you next time. Uh-oh, that'll be taken down.